Okay, so let's do the last part here. So we're going to run these Barton's pendulums, right? And we set the driving amplitude to 2 and the damping to 0.1, all this stuff, and then driving period to 1.6. So that's the middle oscillator, right? And you can see that the middle oscillator is just having a great time, right? Okay. But let's answer these questions, right? So what is the relationship between the driving phase and the phase of the faster oscillator? Well, these guys are, if we're driving it at 1.6, these guys would oscillate faster, okay? So just look at the number 1, that's the best one right there. Notice that when this force is up, that thing's up. When it's at 0, that guy's at 0. When that guy's down, this guy's down. When this guy's at 0, do I have to keep going? That's at 0. This is what we would call in phase. So slow oscillators, these guys, just notice that these guys are in phase. And when we say in phase, that's what we mean. Is that when this guy's down, that guy's down. When this guy's at 0, he's at 0. When this guy's up, this guy's up. Okay? They're in phase. Okay? All right. And then let's look at the slower oscillators. Let's answer this question here. Okay, so these are the slower ones, right? So especially look at 2.2. Some of these are kind of somewhat random. Okay? There's differing degrees, but the 2.2 one is the emblematic of it, okay? Okay, so notice when this guy's up, this guy's down. When this guy's at 0, he's at 0. When this guy is down, when the driver is down, this guy's up. When this guy's at 0, this guy's at 0. When this guy's up, this guy's down, okay? That is what we would call 180, it's hard to say that it's 180 degrees behind, because 180 degrees ahead would be the same. But what we say is that these slower oscillators, okay, are 180 degrees behind. And the reason is that the resonant one is actually 90 degrees behind. We'll talk about that in a second. Okay, so I've slowed this down so you can actually see that. Now, let's answer the question, right? What's the driving phase and the phase of the slower oscillators? This should say, that's a typo. That shouldn't say slower, that should say the resonant oscillator, okay? So what is the relationship between the driving phase and the phase of the resonant oscillator? Well, this is a little bit tricky. Notice that this guy's at 0, this guy was at negative 270. When that guy was at 90, this guy was at 0. When this guy's at 270, this guy's at 90. I'm sorry. So notice that this guy is always 90 degrees behind this guy. So here we are at 90, he's at 180. Now we're at 270, he's at 0, at 180, right? Now we're at 0, he's at 270. Now we're at 90, he's at 0. Now this thing's at 180, this guy's at 90. This guy's now at 270, this guy's at 0, at 180, sorry. And this one gets to 0, this guy's at 270. The 270 being down, right? Okay, I'm talking about like the sine wave. Okay, the sine value, what the y value of this. Okay? So this guy is just crazily 90 degrees out of phase. And the reason for this, and I think I talked about that in another video that you saw, is that maximizes the energy transfer between this and this. Okay, it's a bit like on a swing right now. You're going to start to push them that way, right? You want to time it. And now we're going to push this guy down, right? We're exerting a downward force. And now we're exerting a force upward on it, right? That makes it resonate. That gives the energy transfer at a maximum, okay? I'm just going to stop talking here. Videos. Yeah. So sorry about that.